Okay, what is I to the 241st? Well, let's start with actually what is I? So I is the imaginary number and it stands for the square root of -1. So why is that imaginary? Well, what's underneath the square root sign is supposed to indicate something times itself. But what times itself equals a negative number? Well, we know a negative times a negative is a positive, and a positive times a positive is also a positive. So nothing times itself gets us a negative number, and that's why I is imaginary. So now, back to our original problem, I to the 241st. Well, I repeats itself every 4 powers. So let's take a look at the first 4 powers of I. So I to the 1 is just I. Anything to the 1 is itself. And I to the 2 could be written as I times I, which could be written as the square root of -1 times the square root of -1, which is just -1. So I squared equals -1. Now, I to the 3rd could be written as I squared times I, which could be rewritten as -1 times I, which is just -I. So I to the 3rd is just -I. And finally, I to the 4th could be rewritten as I squared times I squared, which could be rewritten as -1 times -1, which is just 1. So I to the 4th is just 1. And now you'll see we start to repeat. I to the 5th is just I to the 4th times I, which is just 1 times I, which is just I. So I to the 5th is I, and you can see we're starting to repeat now. So if we did I to the 6th, that would be I to the 4th times I squared. And since I to the 4th is just 1, I to the 6th will be I squared, I to the 7th will be I to the 3rd, and so on and so forth. So every 4 exponents of I, we repeat, which means to answer the question I to the 241st, we need to figure out what is left over after we divide all of the repeats of 4 out. So let's do that. 241 divided by 4, and our goal is not to find our answer, but rather to find our remainder. So to remind you of long division, 4 goes into 2 0 times. 4 goes into 24 6 times. 6 times 4 is 24. 24 minus 24 is 0. Bring down that 1. 4 goes in no times, and so that is my remainder. So we go through our pattern of 4 60 times, and then 1 more. So I to the 241st is just I. Let's do it again for another number. Let's do I to the 62nd. Okay, again, we want to know the remainder after we go through all our patterns of 4. So 4 into 62. 4 goes into 6. 1 times 4 is 4. Subtract 2, bring down the 2. 4 goes into 22. 5 times 4, 20, subtract 2, 4 goes into 2, no more times, we're done. So our remainder is 2. So after we do 15 repeats of 4, we have 2 more. So I to the 62 is I squared, which is -1. And that's how we work with large powers of I.